Okay, so we're continuing on from bounds, and we're going to look at error intervals. Now, error intervals have recently been introduced into the GCSE, and they're quite keen on putting questions in about error intervals in both the higher and the foundation. Okay, so it's something we all need to look at. Right, so here's an example. We've got a value x, which is 4.3, and that has been rounded correct to 1 decimal place. So it's already been rounded to 1 decimal place, and we have to write the error interval for x. Okay, now they might ask you to find the upper and lower bound for x. They might ask you to find the lowest possible value of x or the highest possible value of x, or they might ask you to find the error interval. Okay, so what we're going to do is we're going to do the bounds like we did before. Now, if you can't remember how to do bounds, you need to go back and look at the bounds video. So 4.3 is going in the middle. That has been rounded correct to 1 decimal place. So we need to go 1 decimal place higher and 1 decimal place lower. So 1 decimal place higher is 4.4, 1 decimal place lower is 4.2. We then need to find our bounds. So to get our lower bound, we're going to go halfway between 4.2 and 4.3. That will be 4.25. And our upper bound is going to be halfway between 4.3 and 4.4. That will be 4.35. Okay, now the error interval. So this is giving us all the possible values that x can be. So x can be anything that is bigger than, this is the lowest possible value it can be, so it can be anything bigger than 4.25. So x can be bigger than or equal to 4.25. Because if we had 4.25 and we were rounding it to 1 decimal place, it would be 4.3. So it can be anything as small as 4.25 or 4.25 itself. Now, this is our upper bound, 4.35, but hopefully you realise that if you rounded 4.35 to 1 decimal place, it would be 4.4, not 4.3. But if it was 4.34999999, that rounded to 1 decimal place would be 4.3. Okay, so in order to distinguish between the two, we leave it as 4.35 like I talked about in our last video. But because we know it cannot be 4.35, it can be very, very close to, but not exactly 4.35, we say that x has got to be less than 4.35, but not equal to. Okay? Now, if you're quite good with inequalities, hopefully that will make sense. X is bigger than or equal to 4.25, but less than 4.35, and not equal to that. Okay? If you are struggling, don't panic, because the symbols stay the same each time. So if you go lower, you then have this inequality sign with an equal underneath x, and this inequality sign going exactly the same direction, always going that way, okay, and the upper bound. There's your lower bound, there's your upper bound. Okay, let's try again for the second one. So 6.82 is correct to 2 decimal places, so we pop that in the middle. We then go 2 decimal places higher and 2 decimal places lower. We then want to find our lower bound and our upper bound. So our lower bound is going to be halfway between 6.81 and 6.82. So that will be 6.815. And then we want our upper bound is going to be halfway between 6.82 and 6.83. So that will be 6.825. That's our lower, that's our upper. We have been asked for the error interval. So we're going to put, it's called y now, so just watch out for what they've called it. Y has got to be bigger than or equal to our lower bound, but less than our upper bound. And you see what I was saying earlier about the crocodile, the inequality signs just staying the same way? They still stay the same way. Okay? P is 56 round to the nearest integer, so we go 1 integer below, 1 integer above, and we want halfway between. So the lower bound is going to be 55.5, the upper bound is going to be 56.5, and so our error interval, you can draw the crocodiles in before you do anything else if you would like, is that it's bigger than or equal to our lower bound, which is 55.5, and less than our upper bound, which is 56.5. Okay, we've got a couple more just to make sure you're okay with some significant figures. So 19.3 has been rounded to 3 significant figures, so I need to go 3 higher, as in 1 higher, but to 3 significant figures. So the next number that is 3 significant figures, if you see what I mean. And that's 9, and the one lower. and then we're going to go halfway between, so our lower bound is going to be 19.25 and our upper bound is going to be 19.35. And so our error interval, we're called y, so y has got to be less than, not equal, wrong, less than 19.35, but bigger than or equal to 19.25. Okay, and the last one, n, is 568,000, correct to 3 sig fic. So put 568,000 in the middle. We want to go 3 significant figures, but it's got to be higher, so 569,000, 569,000, and 567,000. We've then got to go halfway between. So our lower bound is going to be 567,500, and our upper bound is going to be 568,500. Okay, think about it, halfway between 9,000 and 800, it's going to be 9,000 and 8,000, sorry, it's going to be 8,500. Okay, so our error interval is called an n now, so our n has got to be less than 568,500, but bigger than or equal to 567,500. That is your error interval. Okay, we're next going to look at truncation. Try and get this error interval thing in. Keep doing this every time, okay? Don't try and be clever and go straight from there to there. This step every time, okay? Your lower and upper bounds, really, really important.